This is a Lowell Observatory podcast.
5, 4, 3, 2, 1, 0.
Welcome to Schwarzschild, a space oddity.
Hi, this is Cody Halfmoon and co-host
Haley Osborne.
and this is Star Stuff. And today we're talking about something very near and dear to Haley's heart.
We're talking about black holes.
It's happening.
I'm so excited.
An episode just about black holes. I don't think we did one. I think we've just randomly talked about it.
Yeah, so the very first episode of ours was Black Holes, Space-Time, and Bread, where we kind of talked about black holes, but it was kind of like a chaotic mess of an episode, you know?
Those are so fun, though.
They're so fun. So fun.
Unlike any of our other episodes.
And then, of course, we did the Colliding Black Holes with Dr. Scott Barrows and Dr. Jennifer Hanley.
Yes.
But today, we're not talking about black holes in general. We're actually going in depth into black holes. And
Going into the black holes.
I have been waiting for this episode.
So excited.
I'm so excited because a lot of people don't realize this, but there are multiple classifications of black holes. There's actually 4 classifications and 4 sizes.
Okay.
So the 4 classifications of black holes are Kerr black holes, Kerr-Newman black holes, Reznor-Nordstrom black holes, and Schwarzschild black holes.
Can I just say, if people are going to name things after themselves, can they have simpler names? Can we all just agree as a community that that's ridiculous?
It's not that bad. It's not that bad.
I'm looking at Kerr.
Okay, so these are different languages. These people were I think there were a couple of German people, a couple of Swiss people, I think. So that's why we're not used to seeing this kind of stuff. But if you are into astronomy, you have definitely seen the word Schwarzschild numerous times.
Schwarzschild.
Schwarzschild.
I'm not gonna.
I don't know.
It's
That's
fine.
how I pronounce it. There's a lot of people who say Schwarzschild or whatever.
Schwarzschild.
I say Schwarzschild, but
Okay.
I don't know.
And these are different types of black holes.
These are different types of black holes, and we'll go into depth on what the difference between them all are. But there's also 4 different sizes of black holes. So there are stellar mass black holes, intermediate mass black holes, micro black holes, and supermassive black holes. So supermassive black holes are the ones that are at the center of galaxies. We've talked about those ones before, right? We've talked about that size before.
Right.
And then the other ones are a bit smaller. In some cases, way smaller. Micro black holes are way smaller.
Okay. It's like ordering from Starbucks. The names are confusing.
No, 100%.
Okay,
Yeah.
got it.
But before we get into talking about what each of these means, we have to talk a little bit about a few vocabulary words that we're going to be using.
Right, let's get our words down.
Just so that we have a general idea of what we're going to be talking about. So the first vocabulary, it's not just a word, it's 2 words. The words are gravitational lensing. So gravitational lensing, have you ever had a stain on a tablecloth and you run a stemmed wine glass over it and you see that the stain starts like this and then it goes around the wine glass stem and then it goes back to being normal?
If it's a reference about wine glass and wine stains on tablecloths, I will understand.
Okay, perfect.
Yeah, it just distorts it.
Yeah, it distorts it. And
Yeah.
so that is lensing due to the glass. But in this case, gravitational lensing does a similar thing, but with gravity. So if something is very, very dense, very massive, it can actually cause gravitational lensing. And there's a couple...
Right, because everything has gravity, basically, right?
Yeah, everything has gravity. Certain things have more than others.
Right.
And I guess
So the light bends?
has gravity is a little weird of a way to put it because gravity is a force. It's not really something to have.
Oh.
But it bends light. So there are a couple of pictures that you could usually pull up for this kind of stuff. And I'll pull up one that will drop in the Discord after this. But it's
maybe Nate can put it right here on the video.
Yeah, totally.
It's right here, guys. Look at this photo right here.
So I'm literally just looking up smiley face gravitational lensing, and it is the first thing that pops up.
Oh, it's cute.
It's super cute. So
Oh, it looks
basically,
demented.
it looks wild. So what's happening in this case is, I believe it is a galaxy cluster, is lensing the light behind it. And so these two dots here, and we'll just like somehow edit it
Right
like,
here.
These two dots here.
It might be up here. I don't know how Nate's
I
making
don't
it.
know.
Maybe it's
The
here.
eyes of the smiley face. That's actually the same galaxy, but it's being
What?
lensed. Yeah. It's the same galaxy, but it's being like mirrored basically. And then like same thing here. This is actually the same right here and right here. So gravitational lensing is light bending due to gravity. Does that make sense?
It's wild. But
It's
yeah,
crazy.
it checks out.
So
Okay.
it can be like, sorry, it can be like a galaxy cluster doing this, black holes, dark matter, all kinds of stuff.
Gotcha.
And some of that stuff we'll talk about in later episodes. But in this case, we're talking about it in terms of black holes.
As many episodes as we can sneak in on black holes.
Oh, yeah.
Okay.
But yeah, so it doesn't physically affect the objects being distorted. It just affects the way we perceive them.
Right. Yeah. Gotcha.
Yeah. The next thing that we need to define is angular momentum.
Oof.
So a lot of people who have taken some sort of physics or even a lot of times math or astronomy will have heard this term before, angular momentum. Basically, it is the quantity of rotation of a body.
Haley, stop.
I know.
What?
So something is
Quantity of rotation.
something is
it
rotating.
turns?
Not necessarily how many times it turns, but it's more of like the force of it turning. Angular momentum is I think it's defined as a I think I'm wrong. Hold on. Angular momentum.
Like this, like a spindle tap.
Yeah. Yeah, things that spin. So like Earth
Anything that
spins.
spins. Okay.
Yeah. So this is why I put it in those terms, because like the scientific definition on Wikipedia is the rotational analog of linear momentum.
Oh man.
I don't what?
We need spark notes for this. Oh, what is
angular momentum in simpler terms?
Here we go.
Yeah, so this is what I was talking about.
Yeah.
So basically, as something rotates, you can calculate its angular momentum based off of its mass, velocity, and radius of the object, right?
Okay.
And so we'll talk about angular momentum a little bit. Next up, this one's weird. So the next thing we're going to talk about is baryonic matter. Yep.
Okay. Baryonic.
Baryonic.
Named for Barry.
It's actually named for matter comprised of baryons. So this is more like a particle physics thing, which we should do an episode on particle physics. That would be cool.
Yeah. You need to do an episode.
Fair.
We'll get John in here or something for that one.
So basically, it should have protons and neutrons and all the objects composed of them. So electrons, neutrinos, things like that.
I know all those words.
It can actually exclude things like that because they're leptons, not baryons. It's a whole thing that we're not really going to get into
Dr. Seuss right now.
I know, right?
Okay.
I'm just making up words.
Yeah,
No.
just make it up. You could. Leptons. Okay.
Now, the next definition, which a lot of people have probably heard of before if they've heard anything about black holes whatsoever, is event horizon, right? So event horizon is basically the point of no return. It's where if you pass the event horizon of a black hole, you cannot escape it, right? So a lot of people think of black holes as vacuums sucking things into them. That is not the case, right? You can actually orbit a black hole safely. But as soon as you enter that event horizon, you're falling into it because it's a hole, right? It's literally just a giant gravity funnel leading down to something.
Yeah, I talked to John about like the event horizon once, and he said that if you were to touch a black hole, like what's there, it would probably be like the smoothest surface you've ever touched. And I was like, what? It's not like because I picture like a wormhole or like something, because you see like the graphics. But it's like the event horizon goes to a certain point, then you're getting like sucked in toward a thing.
A singularity is what it's called.
It's like a
it's actually an infinitesimal point out in space. So I usually talk about it in terms of like a grain of sand, because our brains can like comprehend that, but it's an infinitesimally small point in space, and that's what the singularity is, and that's where all the mass and matter is. And so the reason, one of the reasons why black holes have such a large effect on gravity is because they are so ridiculously dense. Like that teeny tiny infinitesimal speck is probably like the weight of our solar system in certain cases more or less than that, depending on the size of the black hole that we're talking about.
So that thing is dense, that little bit.
The singularity.
Like my one brain cell right now.
Yeah, pretty
It's
much.
super dense.
Exactly.
Okay, got it.
And so the thing about when I'm talking about sizes of black holes, I'm not talking about physical size, right? None of these are bigger than others. They have more mass inside of them. So like supermassive black holes have a ton of mass. Micro black holes have way less mass than that. So when I say size of black hole, I'm not talking like a softball versus a golf ball. I'm talking like mass and matter inside of it. Does that make sense?
And they're all itty bitty?
Yep, they're all infinitesimal points out in space.
No way.
Seriously. Yeah. It's crazy. It's crazy.
Really?
Mm-hmm. I promise you.
Oh, okay.
So we got 3 more. So the way I like to think about it is, okay, take your hand, for example. Go ahead and high five me.
Yay.
Yay. So your hand's solid, right? I mean, you felt my hand. I felt your hand.
Mm-hmm.
You're holding your coffee cup right now.
It was
Your hand's
beautiful.
solid, right?
Yes.
Your hand's actually over 99% empty space, because there's empty space between the atoms in your hand, empty space between the bits of those atoms, the quantum bits of those bits. So a black hole is essentially taking out like almost pretty much all of that empty space. And so if you did that to your hand, you would be left with something like a speck of nothingness, you know? So that's basically what this is.
Reminded me of the first time science blew my mind in like 3rd grade. I'm sure everyone did this, where they had like 2 students stand on either side of the room. And they're like, that's like your cells or whatever. It's like your atoms.
Oh, yeah. The
like, no.
distances between things.
Yeah.
Mm-hmm. It's crazy.
Why
It
can't
is
we pass
insane.
through walls, man? It's 2022, 2023, whatever year it is.
Honestly. Okay, so we got 3 more definitions to go through. First off is the ergosphere. It is a region located outside a rotating black hole's outer event horizon. That all makes no sense right now. We are going to fully explain it when we get to those types of black holes.
I'll easily pass right over it.
Next, we have the magnetic moment. So this is the property of a magnet.
It's a cute name. Someone
moment.
romantic wrote that.
But basically, it's the property of a magnet that interacts with an applied field to give a magnetical moment. So imagine like you're putting a magnet up against another magnet, that force you feel, that could be considered a magnetic moment. So
I ship it.
Yeah.
Okay.
And then finally, we have a wormhole, which we briefly brought up. A wormhole is actually a rip in space-time that leads somewhere else. So let's say,
right?
theoretically, these are theoretical objects. We've never found one or anything. But let's say that you want to get from point A up to point B. Right now you have to travel all the way. If you went through a wormhole, if like you opened a wormhole right here, it would be like this, and you just go straight through.
A folded piece of paper.
Exactly. A folded piece of paper.
Do you know where I learned that?
Thor, Love, and Thunder?
Armageddon.
No!
Armageddon! Yeah,
I can't escape
I
it.
am pretty sure it was Armageddon where they were like explaining.
Probably.
Or I'm so wrong and it was Interstellar. Get at me in the comments. I don't remember. It was
I
a
think
space
Interstellar
movie.
definitely
Where
did
they
that
put, like,
because
the
they go through a
pencil.
wormhole. That's Interstellar.
Just kidding.
How could you do that to me? How could you make me think of that horrible movie?
It was so
Okay.
good. Yeah, they like fold a piece of paper and he sticks his pencil through it and he was like, ta-da.
I hate it. Okay.
That makes sense.
Okay. So let's talk about the different types of black holes. So I have mushed together Kerr Newman and Resner Nordstrom black holes for a few reasons. So
Put all the complicated names in one.
So Kerr Newman black holes, they have charge and angular momentum, which means they have some sort of charge associated with them and they are rotating.
Charge like electrical charge?
Yeah. Electrical, magnetic. Yeah.
Like they couldn't
Charge.
get more terrifying.
I know.
Okay, cool.
Resner Nordstrom black holes have charge and no angular momentum. Now, the reason I mushed these two together is because black holes in general are highly theoretical, right? We've seen black holes, we've taken pictures of them now, but we've never been inside a black hole or anything like that. So these two black holes are the least likely to exist. Yeah, because they have charge.
What does that mean?
So it just means that they, have
Like static electricity?
yeah, just like electricity in general, because most things in space have a like net electric charge. These things do not. These have an actual quantifiable electrical charge. Yeah,
Okay.
which is wild. And realistically, it probably, these probably don't exist, but if they do, then we're in for a wild ride.
So why do they think that these exist? Why do they think that a black hole could have an electrical charge?
Math.
Ugh.
The math works out. Yeah. So that's pretty much how most theoretical things happen is math.
Math causes so many problems.
It does. It really does, but I love it anyway.
Yeah.
I'm a psycho. It's fine.
You're crazy.
But
Okay.
basically, a Kerr-Newman black hole only has an event horizon when the combined charge and angular momentum are small, which is weird to think about.
Okay.
Mm-hmm. Yeah.
All right.
But we actually believe that they do have an inner and an outer event horizon. So it's actually got two. And I have a picture of what this could look like right here. And we'll drop these in the Discord, of course. But you
Just
can
looks
see
like an eyeball.
there's the singularity, the inner horizon, and the outer horizon.
So which one is the point of no return then?
The outer.
Oh,
Yeah.
okay.
Yeah.
Just
So-
you're also electrocuted by the time you get to the inner. Just
Kinda.
don't go into one of these guys. Just avoid it. Okay.
So, let's see.
Oh God.
I know. I put a lot of like really fancy schmancy stuff in here
Yeah.
that I'm not gonna say out loud because it makes no sense.
Yeah, it's too much. So much.
It's
But
a lot.
I'm curious about this one-way wormhole thing
Yeah.
because everyone thinks of a wormhole like me.
Mhm.
So everyone
So
being just me.
this one's
probably.
talking about the difference between a charged and an uncharged black hole. The mathematical solution to a charged black hole is that inside its horizon, there is a one-way wormhole that connects to a white hole that propels you to another space and time. So basically...
And this is math.
This is math.
This isn't
math.
Doctor Who. This
No.
is straight math. Okay.
This is straight math. And so you enter into the event horizon, and then you enter into a wormhole, and you are spit out somewhere else in space and time.
But you're spit out like spaghetti. So you're not going to be super useful by the time you get to the other side.
Kind of. It really depends, because the further you go into a black hole, the more an effect gravity has. And so that's what pulls you apart, the spaghettification process, right? It pulls you apart as you enter through. If the wormhole's like right there, you might get there in time before you get like just absolutely obliterated.
Oh.
Yeah.
Okay.
And so, speaking of interstellar, this is most likely what kind of black hole they were talking about, because he enters into that weird dimension instead of being ripped apart. That could be seen as him actually entering into a wormhole inside of that black hole.
That like cube.
Yeah, the
thing.
like cube
Spoilers.
thing that he's in or whatever.
Okay.
Yeah. So
Behind the bookshelf.
I actually looked up pictures of Reznor-Nordstrom black holes for like the diagram and everything, and a lot of stuff that was coming up was the black hole from Interstellar. So
Okay.
I am about 99% sure this is the type of black hole that they were trying to portray on the screen.
Okay. But it probably doesn't exist.
But this is actually what it looks like. Yeah. Or wait, no. This is
Looks the
Reznor-Nordstrom, and so is this. The
Okay.
Kerr-Newman looks like this.
So the Kerr-Newman one, for those listening and not on our Discord, you should be on our Discord.
Totally.
it looks again like an eyeball that's been squished.
Yeah, so Kerr-Newman has a rotation associated with it, which is why it's kind of squished on the top and bottom, whereas the Reznor-Nordstrom doesn't have a rotation associated with it, which is why it's more spherical.
Okay.
And then they've got really weird charge diagrams that I'm not going to explain because that would take forever.
That looks like... We'll put it here, though, and you can trip out over these weird graphics that Haley has found.
100%. But yeah, so that's pretty much all I'm going to talk about with these two because, like I said, they are the least likely to exist because they do have a non-net charge associated with them. Okay. So we're going to continue on.
Moving on.
And next up, we are going to talk. I'm actually going to save that for last. Oh, no, we're going to talk about this one first. So next up, we're going to talk about Schwarzschild black holes. Schwarzschild. So typically when you think of a black hole, you're probably thinking of a Schwarzschild black hole. So Schwarzschild black holes are seen as the solution to Einstein's field equations for general relativity. So Einstein predicted that these kinds of things could be out there, and we ended up taking pictures of them, and we were like, oh, cool.
How did he do that?
Math.
Oh, yeah.
That's just going to be my answer to everything. Yeah. Math.
Man, he must have been bored. Okay.
So,
thanks, Einstein.
Schwarzschild black holes are characterized by the event horizon, and the radius from the singularity to the event horizon is called the Schwarzschild radius. Yeah.
Okay.
We got a picture. So
from the singularity in the middle to the edge of the... Okay.
Schwarzschild radius. Yeah. So if you fall in, you notice...
Is it kind of like an ice cream cone? Like, you know how you have ice cream cones, but then like they have a little chocolate bit at the bottom of the cone, all smushed at the bottom? Like that's the singularity.
Yes and no.
Like if you're looking at it and you like get sucked down the cone to the chocolate?
So kind of, but they're spheres.
Okay, yeah.
So it'd be like an ice cream cone where it's a sphere and the cones all point in. Yeah. Very odd to think about. I actually have a tattoo of a black hole diagram right here, if you guys can see it. So there's my black hole diagram. But yeah, we've got the event horizon. If this were up, that's more what it would be. And then these would go down forever into
the chocolate.
The chocolate.
Singularity. Yeah. Gotcha. Okay.
So with Schwarzschild black holes, if you fall in, you notice no physical surface, but you would be spaghettified. Yeah, so you just bloop, and you're gone.
Okay. This is just a normie black hole, like what we think of.
Yeah, it's what we typically think of. Okay. Even stars and planets have a Schwarzschild radii associated with them, so that gets a little weird. I'm gonna kind of bypass that because we're talking about black holes here, but fun fact. But yeah. So these black holes have no charge and no angular momentum associated with them. Okay,
so they're not spinning. They're just levitating in space, being creepy.
Pretty much. Yeah.
Okay. I thought everything spun in space.
Yes, which is why these are not as likely to exist as the next ones that we're going to talk about.
Oh my gosh.
Because they're not spinning. Yeah.
Okay.
So... yeah, this type of black hole gravitationally lenses objects. So we talked about gravitational lensing. Now, the most likely to exist in space are Kerr black holes because they have no charge and they have angular momentum, which is what most things in space have. So basically, and this is where it gets weird because according to the fact that it has a spin and it doesn't have a charge, and these are most likely to exist based off of those two facts, that makes this next part really weird to think about. They should have an inner event horizon, and that inner event horizon suggests that there's a second universe.
Shut the door.
I'm dead serious.
What?
Yeah. If you look up Kerr black holes, that's like one of the main things that's talked about with these. Because
we're going AU right now? Like, wait.
It's so weird to think about because like so from what I've seen, all black holes that we've seen so far have spin associated with them, and we can tell because of the way that they're photographed. So in this, I included images of the supermassive black holes that we've taken pictures of. So if you look here, the bottom of this picture right here is lighter and the top is a little darker, that indicates that this is spinning and this part is coming towards us and that part is going away from us. So this black hole is definitely spinning, which makes it either a Kerr black hole or I believe a Kerr-Newman black hole.
But one of those is less likely to exist because of the charge element.
Exactly.
See, I'm catching.
Exactly.
Where's my
Exactly.
PhD? Okay.
So
we go back to the alternate or second universe thing.
Basically, it is possible to avoid the singularity and it exit somewhere else.
How? Math. So, but why this and not the other one? Like, why does this one?
Because most things in space have angular momentum and a net charge. And that is what Kerr black holes are, is angular momentum and a net charge.
How would math show an alternate universe? Like, are they just doing an equation and they put it in the calculator and it just says alternate universe?
No, they come up with the equations and based off of certain things, it spits out.
That would mean each black hole has its own.
That's genuinely math that I cannot explain because
Are we
I
in
don't
a black
get it.
hole? Like this universe? I broke her brain. It happened. Because usually when you think about universes, you think like, oh, we might be in like a pocket universe, and at the edge of our universe, which there isn't one, whatever, there's like another universe, but we can't interact with it because our math doesn't work out, so we just don't see these. But if we're looking at black holes, and then there's an alternate universe, then they could be looking at a black hole and be like, oh, look.
I'm gonna throw up.
Like maybe there's a grasshopper version of us doing a podcast in a different black hole.
You know, I love that. I want that now.
That's
it's crazy, but yeah. So
I just read something from her outline, which I purposely do not do before these episodes. What?
So. It is possible to avoid the singularity and exit somewhere else. That's what we just said. Since you are not only traveling through space, you are also traveling through time, it is entirely possible that you can go back in time, and that leads to a grandfather paradox.
No.
Yep. So it's definitely an interesting
grandfather
thing to
paradox.
talk about.
That's Back to the Future. Basically,
Yep.
Back to the Future is a documentary about a grandfather paradox and the disappearing photos and all of that, which is different than a time paradox, which is where you affect the past that leads to what happens in your, like, what you experience.
Yeah, so let me give you like the official definition of grandfather paradox.
Which, like, I feel like time paradox is also like that moment in The Matrix when she's like, don't worry about the vase, and he's like, what? And then he knocks over the vase. Like that was always going to happen, but anyway.
So basically, the name comes from the idea that if a person travels to a time before their grandfather had children and kills him, it would make their own birth impossible. So that's a grandfather paradox, which leads to some interesting side effects. So the fact that, like, mathematically and based off of what we know of the things that we've seen in our universe, the fact that mathematically a Kerr black hole is most likely to exist, it's...
And that's the one with all of the time travel and all of the other universes, just so that we're completely clear on what's most likely to exist. And this is math.
This is math.
This isn't a tin hat.
Yeah, no, this isn't a tinfoil hat. This isn't a conspiracy theory. This is, like, mathematically... numerous physicists and astrophysicists have come up with these conclusions.
And is that why maybe Einstein was saying that you could only go back in time but not forward?
I don't know. I haven't actually heard that.
Or was
before.
that just on a show that I watched?
That
Never
might have been
mind.
Back to the Future. I don't know.
Yeah, you can't go.
No, actually, I don't know.
back.
I haven't heard anything about that. But
Okay.
But yeah, so the fact that the pictures that we have taken of black holes show that they are, in fact, rotating means that these pretty much must be Kerr black holes or Kerr-Newman black holes.
Which exist in math because it also includes the other universes and the time travel.
The math indicates that this could be a thing. There could be a second universe according to the inner event horizon existing within a Kerr black hole. It's weird. It's very odd to think about. It hurts my brain to think about, especially because of the fact that, like, in my opinion, and like, get on the Discord and argue with me if you think that I'm completely wrong about this, but in my opinion, if there is a second universe, I feel like that means that there's gotta be infinite universes.
Well, if
Like,
each
there's
black
no
hole
way.
has one.
Yeah. But there's like no way that there's just two. Like, that doesn't make sense. I feel like there's either got to be one or there's got to be infinite.
Right.
That's the only thing that makes sense in my brain anyway.
Well, and also, like, if this black hole has a universe based on math,
Mhm.
it's not the only black hole like that.
Yeah.
So do they all lead to this other universe, or do they each have their own universe?
Exactly. I don't know.
And I want to know what black hole I'm in.
Totally.
I'm so glad that you broke my brain this much at the end of the episode.
Mhm.
I do have a question, though. When you're talking micro black holes, are those the itty bitty ones that happen?
Yeah, itty bitty, teeny tiny micro black holes. A lot of people, like, for example, when CERN was built, they were worried that they were going to create a black hole that was going to
CERN?
collapse everything. Oh, so CERN is the particle collider, is what I'm talking about. So
Humans stop.
it's wild. It's wild. But CERN is so cool. And the particle collider has done a lot of really cool stuff. It's what found the Higgs boson particle, the God particle. And so a lot of people were really worried about CERN. Like,
Humans need to
accidentally.
touch grass.
I know.
Like,
I know.
stop.
But like, a lot of people were worried that
Get
it
a
was going to
hobby.
create this like Earth-destroying black hole. In all reality, like, if it were to create a black hole, it would be a micro black hole that would immediately. Oh, I don't want to say it because that means I'm going to have to explain it.
What?
It would evaporate.
The black hole would evaporate. So it just come up and then bloop away.
So black holes, technically, by definition, like, they trap everything in them. They don't, like, you can't escape it. You have to go twice the speed of light to escape it. There is something called Hawking radiation. Black holes actually emit very tiny amounts of radiation, and so slowly over time they evaporate. And we don't 100% know why. They evaporate. They let off tiny amounts of radiation, which should not happen according to the fact that their escape velocity, the speed required to leave a black hole's event horizon, is literally twice the speed of light. Like, the speed of light is 3 times 10 to the 8th meters per second. The escape velocity of black hole is like 6.67 times 10 to the 8th meters per second, which is over twice the speed of light. Which nothing goes faster than the speed of light, yet we see that these black holes are actually letting off tiny amounts of radiation and they're slowly evaporating over time, and it makes no sense, like, what is happening. And so there's like a lot of theories about what could be
It's
happening.
very progressive. Like, they're, you know what I mean? Like, they're collecting a bunch of junk and then they're just taking care of it and emitting it back. It's a nice green cycle. I'm assuming this radiation's not a good word, though. It's
Radiation's
really
not
like
a bad word. Everything
oh.
radiates. You and I radiate heat. Yeah.
So these little itty bitty ones, they just bloop, 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 bloop.
Mhm.
Would those be, I'm blooping because they're showing up in the air, and that's scientifically the sound that they make when they evaporate, these micro black holes. Would those be Kerr black holes, the micro ones?
No idea.
And if they were, are those itty bitty little universes that bloop into existence and then bloop out?
Honestly, like, all 4 of the categories of black holes probably could have any of the 4 size of black holes associated with them. So you could probably have like supermassive Kerr black holes versus like micro Kerr black holes. I'm not entirely sure like what the I guess probability of the like size for these different black holes could be, but like with Kerr black holes and Kerr-Newman black holes, we know like based off of the math, unless we got something super duper wrong, we know that they pretty much have to exist because of the pictures that we've taken of supermassive black holes. And so if they for sure exist, like if we didn't get the math wrong, if we didn't get anything wrong, if these supermassive black holes are Kerr black holes or Kerr-Newman black holes, we know that for a fact they can exist as supermassive black holes. Whether they can exist as stellar mass black holes, intermediate mass, or micro black holes, we haven't really seen a whole lot of black holes like that. Like we've never taken a picture of one ever, but we've seen effects that could be like stellar mass black holes, things like that.
So our black hole in the Milky Way is a Kerr.
Or a Kerr-Newman.
Or a Kerr-Newman.
Mm-hmm. Yeah, because it definitely spins. We know that it spins based off of the picture we've taken. But I don't know for sure if we've seen any indication that there might be a charge associated with it.
But likely not, because
Likely not.
Most likely not a thing for a black hole to
It's
be charged.
most likely a net neutral, and that means that it would be a Kerr black hole, which is why those are the most likely to exist in space, according to everything I've
Those are
read.
the trippiest.
I know.
So the black hole in the center of the Milky Way, our Milky Way galaxy, could also be a wormhole to an alternate, or a some sort of event horizon door to an alternate universe, and time travel.
Yeah.
That's all we have for today's episode, because I need to process that.
Fair. To be fair, I did say at the beginning that Resner-Nordstrom and Kerr-Newman black holes could potentially have one-way wormholes inside of them, which is basically what I'm talking about with Kerr black holes.
Same thing. That's great.
So more than likely, black holes have wormholes inside of them.
Because 3 out of the 4 theorized black holes involve wormholes.
Pretty much. Pretty much.
Cool,
So, yeah.
And you just walk around with this knowledge in your brain.
Yeah, I kind of hate everything.
You just like pay bills and
I just pay
respond
bills.
to texts,
Yep.
knowing that there might be an alternate universe in the center of a galaxy.
Yeah, I'm a big, firm believer in the multiverse, but that's just because I've read so many things about things like this, and I'm just like convinced, like, there's no way that there's not, you know, because it's either in my brain, and I worked through this, and I'm not going to like explain my entire thought process because we are pretty much out of time, but in my brain, like, there is either one universe or infinite universes.
Right.
And infinite universes just makes more sense than just a single universe to me. So I've
read plenty of AU fanfic. Like, I am so on board with
Perfect.
the AU stuff. It's super fun.
Yeah.
My brain is broken, though.
Oh,
so
yeah.
is there anything we needed to cover else? Because my brain, that broke me, Haley. We did not
I
talk
know.
about this in our previous black hole episodes. And I feel like that was on purpose because you knew it would derail.
No, 100%. There was a reason that I haven't brought this up until we had an entire episode dedicated to it, because at the beginning of COVID, we educators had a bunch of stuff that we were doing because we were closed down to the public and we needed something to fill hours. One of the things was, make a short 5-minute video on something that interests you. And so and we could make more than one. So I made 4 on the different types of black holes. And even those that was not enough time. So I was like,
My hands are sweating. I know I've said that before in a podcast recording, but my hands are clammy.
Well,
On that note,
to all our listeners out there, we would like to remind you that we have a Discord. All of the images that I referenced will be in that Discord. We're going to try and see if we can like pop up the images as we're talking about them, but
Nate can totally.
Nate said yes.
Nate's got
Nate can do this. Perfect. So
can you put the smiley face
Yes,
one
definitely
over
the
my
smiley
head?
face.
He's behind the camera. Can you put it like over my head? You're really funny.
wonderful.
Just while she's talking, like, oh.
But yeah, so feel free to get in our Discord channel if there's anything that I said that you think is wrong or that you would like to expand upon. At me, I'm in the Discord channel. Actually, I have the glasses. I can do it. But yeah, so thank you guys so much for joining us. Cody, I'm so sorry I broke your brain.
Again.
Again, as usual.
Why do I do this?
You love me.
I love you. Yes. Thanks,
Alrighty.
guys. Holy crap.
Thanks, guys.
What an episode.
Hope you enjoyed it. Bye.
Bye.
This podcast was made possible by our members and donors. If you enjoyed this episode and want to support our nonprofit in making more digital education like this available, go to lowell.edu/donate. Thanks for listening.